A multi-trillion-dollar damage solar storm awaits, and it could literally be the end of the world as we know it because of the fact that we're electrically connected. It's inevitable. A giant solar storm could be coming soon, and nothing can stop it. It's been more than 150 years since one happened, and back then damage was limited because technology was scarce. We didn't have electricity. Well, very little actually, but that's not the case anymore. Humanity is not prepared and may never be prepared if this happens again. So the end of the world, according to the Bible, to come in fire, this is how it could happen. The sun is, as we know, 1 AU from us. It's the distance between the Earth and the sun, 93 million miles. A fiery star capable of causing ultimate extinction event in a number of ways. And one of them is, of course, is these solar flares if they're facing us. Why we're at risk now more than ever? It's because of the sunspots, or what we call space weather. Space weather events occurred throughout history, and they would have posed no danger to humans or our planet. But today, all is different. The massive amounts of electricity-based infrastructure that covers our planet, and the danger is palpable. In February of 2021, an estimated 4.4 million Texans lost their power due to a winter storm, and according to a recent report in Big Think, the event of a grid overload space weather event, there could be over 1 billion people across the world left without power, a natural disaster without precedent in the world. So that's what makes space weather so dangerous for us here on Earth. Not that it poses direct threat to humans, but because of the enormous electrical current to flow through the wires connecting our infrastructure. So this is what happens. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Electrical shorts, fires, explosions, blackouts, power outages, loss of communications infrastructure, many other damage that would appear downstream. The major issue with the infrastructure set up for large-scale production and transmission of power, there will be uncontrollable surges that will knock out power stations and substations and pump far too much current into the cities and buildings, and downstream casualties could be massive, depending on how long it would take to restore heat and water, for example. That would be something like the 1859's Carrington event. That's when solar astronomer Richard Carrington was tracking a particularly large, irregular sunspot, and all of a sudden a white light flare was observed with unprecedented brightness lasting about 5 minutes. Quote, approximately 18 hours later, the largest geomagnetic storm in recorded history occurred on Earth. Aurora were visible worldwide, including at the equator. Can you imagine living at the equator where you're not supposed to see northern lights and they saw them? Miners awoke in the middle of the night thinking it was dawn. Newspapers could be read by the light of the aurora, and troublingly, telegraph systems began sparking and igniting fires, even though they were disconnected entirely. End quote. So you can imagine what was going on. And that was it. The minor damage was negligible, but that was back in 1859. So we have to think of now that we have a global society and it's become so reliant on electricity. Today, it would be an apocalypse. Quote, the sun emits all sorts of space weather in random directions, and every once in a while, Earth is right in its crosshairs, the Big Think says. They said when a coronal mass ejection's magnetic field is anti-aligned with Earth's, it can induce a very dangerous geomagnetic storm, end quote. And the world has never been in more danger because of our reliance, of course, on electricity for the past 250 years. Big Think says, when we think about the sun, we normally think about 2 things. The internal source of its power, nuclear fusion in its core, and the radiation that it emits from its photosphere, warming and powering all sorts of biological and chemical processes on Earth and elsewhere in the solar system. These are two of the major processes involving our sun, to be sure, but there are others. In particular, if we take a close examination of the sun's outermost layers, we find that there are loops, tendrils, and even streams of hot ionized plasma, atoms that are so hot that their electrons were stripped away, leaving only bare atomic nuclei. Space weather events have occurred throughout history, and they would have posed almost no danger to humans. The only visible effects would be a spectacular auroral display. Now, on June 23rd, 2012, the sun emitted a solar flare that was just as energetic as the 1859's Carrington event. It was the first time that it had occurred since we've developed the tools capable of monitoring the sun to the necessary precision. The flare occurred in Earth's orbital plane, but the particles missed us, thank goodness, by the equivalent of 9 days. Similar to the Carrington event, the particles traveled from the sun to Earth in only 17 hours. If Earth had been in the way at that time, the global damage could have crested to $10 trillion mark, the first 14-figure natural disaster in history. It was only through luck that we were averted that catastrophe. So is this just another thing to worry about? Now, the thing is, what can we do to avert this? Here we are in space weather. X-ray solar flares, 6-hour maximum 6.1, 24 hours C7. These are our solar flares. 1, 2, 3, 4, 5, 6, 7, 8. And chance of Christmas storm updated. Multiple M-class solar flares this week have hurled at least 2 faint CMEs towards Earth. NOAA forecast models predict glancing blows today and tomorrow. Today, Christmas Eve, and tomorrow, Christmas. The impacts, albeit weak, could combine to produce a G1 class geomagnetic storm and high altitude auroras during Christmas holidays. So the G1 class storm, geomagnetic storm impacts, weak power grid fluctuations can occur. Spacecraft operations, minor impact on satellite operations possible. Other systems, migratory animals are affected at this and higher levels. Aurora is commonly visible at high altitudes, northern Michigan and Maine. So we're going into solar maximum, and we seem to be having solar storms just about every 2 or 3 days now. I mean, that's a lot, don't you think? So all of you in the, around the Great Lakes area, across the border in Canada, I'm sure you'll be able to see wonderful auroras. Okay, like this one here, for example. Wonderful. This is from Norway. It's Svalbard in Norway, close to the North Pole. Please leave your comments, and thank you for your support.